This is part 2 of estimating a population mean. Alright, so in our last video, we talked about calculating a point estimate for the population mean. We said that was simply our sample mean. That is our best point estimate for the estimating the population mean. But as we spoke about in the previous section, in section 9.1, we said that an interval estimate or a confidence interval is a better way to estimate the population mean. So that's what we're going to talk about, both constructing and interpreting those intervals. We're also going to look at part C of the problem that I have, is finding a required sample size that we would need if we wanted to conduct our own study. So we'll see parts of each of these in this video. Alright, so the example we have for this video is similar to what we were working with in the first part. The difference is we have more data. So an agricultural researcher is interested in estimating the mean length of the growing season in a region. Treating the last 20 years as a simple random sample, he obtains the following data, which represents the number of days of the growing season. So of course this data will be on the next slide, but we've got 20 data points now instead of just 10. And the first thing we want to do is confirm those requirements that we spoke about in part 1. Make sure, can we use this t distribution and the t-interval function on our calculators? Alright, so I've gone ahead and written down the 3 things that we need to check based on whether or not we can use the t-interval. The first one is this a simple random sample or a randomized experiment? In this case, we are told to treat the last 20 years as a simple random sample. So we can say that that condition is met. And then, is our sample size less than or equal to or no more than 5% of the population size? Well, the past 20 years, if we think about, how many years of growing seasons, they've been growing things for millennia. So I think we're safe to say that 20 years is definitely a small enough sample from our entire population. And then to check to see if it's normal without outliers. That's our third question. And there's 2 things that we're going to do. We're going to check the histogram for this data, and we're going to check the box plot. So if you remember from chapter 3 and chapter 2, when we drew these on our calculators, you can do, once you've entered this data into L1, you can do second y equals, and you can find the graphs for these things. Let's see if I've got a picture of that. All right, so I've got what we would look like in our windows. We would go to second y equals, turn our plot on, and draw a modified box plot. We want to make sure we do that modified box plot so that we can get those outliers showing. And then, of course, we can graph. But before I graph, I also want to go ahead and do a histogram. So a histogram is going to show me if it's normally distributed or not, or approximately normal. So what I want to do then is, I could do zoom 9 for zoom stat, but I'm also, I did that and it didn't look great. The graphs were overlapping. So I changed my window and I made my window look like this. All right, so here's my window settings. I set my min and max. This actually ended up being much smaller than it needed to, but it works out. So my minimum and maximum on my x value, that's going to be my horizontal axis. And then my x scale was 6. That's going to be the width of each bar. And then my y min and y max, that's just going to be how tall the graph is, so that both graphs, both the histogram and the box plot, can be in the same window. So once I made those settings, here's what my graph looked like. So I've got a box plot that looks very nearly symmetric. There are no outliers. That's the main thing with the box plot that we're looking for. And then if we look at the histogram, it's also very nice and symmetric, single peaked. And so we can say that, yes, we have this situation that we were looking for where we have a normal or approximately normal distribution with no outliers. All right, so now that we know that we can use our t-interval, that's what we're going to do. So we've got our data in L1, and we want to construct and interpret a 99% confidence interval for the mean number of days in the growing season. I want to make sure that I point out a couple of things that are pretty important. For one, it says it has the word mean in our problem, and that's what lets us know we need to use the t-interval instead of the one prop z-int. Remember that one prop z-int, that prop is for proportion. So t-interval doesn't have the word mean in it, but when we see this, when we see the word mean in our problem and we're asked to find a confidence interval for a mean, we're going to use t-interval. The other thing to point out is just to make sure that we remember what is our confidence level, because that's going to be different depending on our problem. We might have a 98, 99, 95, 90%. Some of your homework problems even have 80%. So make sure you're paying attention to that when we're putting this into the calculator. All right, so again, here we're wanting to construct and interpret a 99% confidence interval for the mean number of days in the growing season. So to do that, of course, we're going to start by going in and making sure we have our data in our list. So again, I've put the new data in L1. So this is not the same data that we had for the first video. This has got the 20 new data points that were on the previous slide. So they should be in there where we drew our histogram, and that should be good. So we're going to go over to our tests. We're going to remember to skip over the tests. I'm going to just go straight to number 8 because 8 is our t-interval. I do have data, and so I'm going to leave that. My data is in L1. Frequency will stay 1. And then remember, our confidence interval was 99%. So I'm going to change that to 0.99 before I calculate. When I hit calculate, it's going to give me all my wonderful information. Not only does it give me my confidence interval, but it also gives me my sample mean and sample standard deviation and reminds me of my sample size. So this is great. We don't have to do the we don't have to do the one variable stats. We can just run our t-interval and that will give us the values that we need. We don't need those right now, but if we did, we would have them. Instead, we're going to take a look at this confidence interval. That, let's see, right here, and we're going to interpret that in context with the problem. So again, we always want to identify how confident we are. So we are 99% confident that, and then I'm just going to reuse the words that the problem is asking me to find the confidence interval for. That gives me the context I need for the problem. So we are 99% confident that the mean number of days in the growing season is between, and then I'm just going to use these numbers that my calculator gave me. 160.81 days and 174.99 days. And there we go. I've got a wonderful interpretation of that confidence interval. It's in context with the problem. It tells how confident we are, and it has our lower and upper bound of the confidence interval included. All right, so this last part, part C here, we've got a farmers association that wishes to conduct their own study to to determine the mean length of the growing season in their region. What sample size would be needed for the estimate to be within 7 days with 95% confidence if we use the sample standard deviation found in the previous study? So here's where having that mean and standard deviation along with the confidence interval is very handy. We don't have to go back and do one of our stats. And I went back and looked, and we had a mean of 167.9 and a standard deviation of 11.08. Of course, that kept going. Or since we've talked about rounding our statistics to 1 decimal place further than the data, we would really just round that to 11.1. And so we'll see what happens when we put both of those values in and see how different it changes our sample size needed. But we're going to use the Excel file for this. So again, this is the same Excel file that we used from Momentum that it had at the top was how to get the required sample size for a proportion, and then at the bottom it had required sample size for a mean. So we're going to use that bottom calculation for this problem. All right, so if we're trying to find out what sample size do we need in order to be 95% confident that our interval is within 7 days of the true population mean, then what we want to do is go back to this Excel file, and we want to use the sample size to estimate a population mean. So that's this second one down here in our Excel file. So again, that you can find this file in Momentum under the content section. In my folder, it's under chapters 8, 9, and 10. That's one folder, and then this is a file in that folder. If you have a different professor, then that file may be somewhere else, or they may have a different way for you to calculate this. Also, if you have the school calculators, if you go to programs, there is a program called SS Mean. It will ask you for these same 3 values. It may or may not be in the same order. I can't remember right off the top of my head, but you'll want your confidence level, your margin of error, and your standard deviation. These 3 things are still what you need to use that SS Mean. So if you have that and want to use that, you can. All right, so we want to be within 7 days. Now, one thing to be careful of course, 7 days is a week, and some of your homework problems might say something like that. They'll give you your data in hours, but then say they want it to be within a day, and so you've got to change that to be within 24 hours. Or this might have said what sample size is needed in order for our to be within 1 week, and you've got to change that to 7 days. You've got to make sure that your margin of error, which is this value that we're given here, that this margin of error is in the same units that our confidence interval data or whatever, that it's in that same context. Of course, we need our mean and standard deviation also, and our units for our mean and our units for our standard deviation are going to be in these same units, and our units were days. All right, so to plug these in, of course, the first thing we've got to do is fix our confidence level, because the file just has a random number in it. It's 0.99 right now. We want to make sure and change that to 0.95 since we want to be 95% confident that we're within this range. Our margin of error, this is just going to be a value within the units, so 7 days. And then our standard deviation from before was 11.1. When we calculate, that means we need a 9.65. Of course, we always want to round up, so that would round up to 10. Now, I said we rounded our standard deviation. What if we put in 11.08? Well, if we do that, we'll get a very close to the same size. So our sample size needed would still round up to 10 years. So we would need 10, our sample size would need to be 10 years in order for us to be within 7 days. So our required sample size is 10. Now, interestingly enough, we actually got a confidence interval within 7 days. If we look at what we got with our 99% confidence interval, we had 20 years, and so this was probably rounded the numbers a little bit on our confidence interval. This probably would have been 19 point something if we had calculated it. But if you notice, look at our confidence interval. Our confidence interval, when I rounded to the nearest whole number, was 161 days, to 175 days. If we subtract that, that's 14 days. And what that means is that in our confidence interval, here's that 175, and here's 161. This was 7 days above and 7 days below in order to get from whatever our mean was. And our mean was, if we round, 178 point something. But, oh, sorry, not 178, 168. My bad. Hold on. Change that. Could have been 178, because 178 would have been higher than 175, and obviously not in the middle. I saw the 75 and the 2 7s for 7 days, and I think I just got the 7s, ran away with me. So that sample mean that we had was very close to 168. It was 168 point something, or 167 point something. And so if we look at this is really kind of cool how we already had this within 1 week, and we would need less years to use as an estimate because we are less confident than we were here. So we're only 95% confident with our sample size of 10, but we can be 99% confident that it's within 7 days for these, if we used our 20 years that we had.